This is the Earth at a time when the dinosaurs roamed a lush and fertile planet. A piece of rock just 6 miles wide changed all that.
Welcome to the Expanding Universe.
I'm Ryan Marciniak.
I'm Jesse Robertson.
Let's get right to it.
We're talking about asteroids, specifically near-Earth asteroids, but I guess all of the asteroids in our solar system. And actually, as we'll see later, maybe asteroids outside of our solar system that visit for a short amount of time. Now, the reason I wanted to talk about it is I think this is a topic that lots of people can take an interest in because it has an actual physical possible impact on your life, and I use that word impacts in both ways because an asteroid could hit Earth, and it's unlikely, as we'll talk about, it's unlikely that anything is ever going to hurt you or kill you from space, but it could happen, and we saw this in 2012 in Russia. All of this stuff we'll get to. So it was spurred, the idea was spurred because a few weeks ago in early October, an asteroid called 2012 TC4 flew by Earth. And when I say flew by, I mean it got to as close as 50,000 kilometers from Earth. And to put that in perspective, the moon, our moon, is 400,000 kilometers away, and geosynchronous satellites are at about 40,000-ish kilometers from Earth. So this asteroid, 2012 TC4, flew just outside the range of our furthest satellites, and that would be considered a pretty close shave. Of course, still 50,000 kilometers is pretty far. Now, the asteroid itself was about 20 meters in size, so it's about the size of a large house. Roughly, and went whizzing by at a ridiculous speed of like 50, 60,000 kilometers an hour, something like that, and reminded everybody on Earth that this stuff is flying around. And then it naturally gets us to ask the questions, what's the likelihood of impact from an asteroid? What kind of damage would one that big do? What's the most likely one to hit us? All of these questions. And that's the kind of the topics I want to get into with 2012 TC4.
Wow.
Yeah, that's the whole intro.
It's pretty...
Are you worried about asteroids?
I get more and more worried every day. Because I think that, we start talking about... Now we're starting to see more and more of these near-Earth asteroids, these close shaves, these ones that come inside the moon. And for me, anything close is within... closer to the moon is than the Earth. That's a close shave for me.
Those are
384,000 kilometers. So that's 6 times as far as this TC, was it 4?
Yeah, 2012 TC4.
This is why we don't remember designations, right? But
stupid name.
But I think there's more of these happening because we're better at tracking them. We're starting to get much better at tracking smaller and smaller asteroids, which is important because you're talking an asteroid 20 meters wide. Now that isn't going to destroy the planet.
Not even close. No.
Right. Not even close to that. But if that hits the ground, that can do some significant damage, especially if it hit a city, of course. I mean, the odds of that are really low, and I'm getting into the whole science fiction thing. But the idea is that we're starting to see more and more rocks because there are a lot of them out there. And for the longest time, we didn't know that there were very many of them out there.
There's two projects that I know of that are making this really, really easy, two projects that make it easy to find these objects. One is a Canadian-led one called NEOWISE. It's a briefcase-sized satellite in orbit around Earth called the Near Earth Object something or other, or whatever. I don't know. It's a
I like that name, the something or other,
yeah.
whatever.
It's a satellite telescope, a telescope in space, a space telescope, as you were, and its job is to look for near Earth objects. So that's one. The second one, and the one that made 2012 TC4 so obvious to us, was the Pan-STARRS All-Skies Survey, which surveys the entire sky that can be seen from Hawaii on a very often. So it's taking multiple images of the sky, and you can watch as things move through it much better. And there's another telescope that's going to come online in the next 5 to 10 years called the Large Synoptic Survey Telescope. Mm-hmm. And it's going to be imaging the sky like every 3 days, like the whole sky every 3 days or something like that.
Which is really ambitious.
Yeah.
I saw a talk from Jill Tarter from SETI a couple weeks ago.
Oh, lucky.
Yeah, and she was talking about the goal being looking at the sky all the time and the entire sky across the entire electromagnetic spectrum. Continually. Because
that
that's
is the goal.
The only way that we're going to be able to locate some sort of signal from whatever potential life is out there. Now, this is getting off topic a little bit, but that is the goal, is to be able to see all of the things that we might miss as humans because we're not always looking up, right? And I don't think people realize how often things are actually hitting the Earth, right? We get cosmic dust every day, something like 10,000 tons.
So I was going to ask you that, like, so there's estimates. I've seen estimates all over the place. There's estimates from 1,000 tons to upwards of 10,000 tons amount of matter falling onto Earth every day. I don't know I don't even know how you estimate that.
Well, I think it puts it in perspective, at least, to say more than 1 ton of dust is falling to Earth. And that's a lot. I mean, that is over the entire Earth, but that's every day. And I know when I go outside and I think about meteor showers, and you think, oh, that'd be really cool to see a couple meteors and go, and, let's go. We always watch the Perseids in August, right? And that's the best meteor shower of the year. Gets up to almost 100 an hour if you get a really good one. 100 meteors in a 60-minute span. Most of them are decent size, so they're pretty bright. That's a good meteor shower. But I don't think a lot of people realize that when you just go outside on a dark, clear night, if you had a good dark sky, you would see a couple meteors an hour just because you're on the Earth and stuff is falling toward the Earth.
Yeah, and if you look around and try and tally it up over the whole Earth, we get this massive amount of material.
Yes, yeah.
Falling on.
Yeah, and I mean most meteors that we see are just really small, right? They're just moving really fast, and so the friction of the atmosphere, they get that bright burn. But
they're tiny. Those things are like pebble size.
Yeah, exactly. But they add up, right? And even dust smaller than that adds up, and bigger than that adds up. There's still a lot of stuff falling around the Earth every single day. And I can't remember who it was. I'll have to look up the quote, but there was an astronomer, I guess planetary scientist or an asteroid astronomer.
Asteroidologist?
Sure, let's call them that.
An assologist?
Well, they probably wouldn't like that name as much. But yeah, so I mean, it was somebody saying that if you could see all of the objects that were out in the solar system, you would be terrified because there are so many objects. And even if you pick the objects larger than a kilometer in size, you would be just blown away by how many there are.
Okay, so there's a good thing to point out. There's range limits on what kind of damage would happen if it hits Earth. So the one that flew by a couple weeks ago in early October 2017 was 20 meters, and if that hit Earth, it would likely airburst. So there's a good analogy to this one. It would be very similar to the one that airburst over Chelyabinsk back in 2012.
Nice.
Do you remember that one?
Yeah. I had to learn to say Chelyabinsk.
I don't even know if that's correct. My apologies to the Russians listening. So that one was probably roughly the same size. It exploded in the air. It burst windows, knocked out doors and garage doors and stuff like that. Many people were injured. Nobody was killed. It did end up hitting the ground, went much, much smaller. It was only like a couple of meters or maybe a meter in size when it got to the ground. And so that's the kind of damage you talk. We don't know where all of those ones are. We have no idea where they all are. So they could be coming from anywhere, and we could get hit tomorrow by one roughly that size, and people would be injured again. But how big do you have to go before it would start being something really dangerous?
Yeah, and let's get one thing clear too, is that these things are not, they're not soft pillows. They're chunks of rock, and in many cases chunks of solid iron.
Yeah.
Which makes them even more dangerous.
Very dense.
Right? Very common meteorites are iron, stony iron, incredibly dense, moving at several kilometers per second. It's just a huge amount of energy coming down. And those are the small ones too, right? So that kilometer in size, that's big enough that people will take notice. And Chelyabinsk, I think, was a once in a century event based on statistics, right? The other one that comes to mind is what the Tunguska event probably was.
Oh, yes. Of course. And that one would have been...
I think.
That was 1905.
Yeah.
Or was it 1908?
Somewhere around there, the first decade of the 20th century. But,
I think that would have been larger.
Probably.
Slightly larger.
Yeah, probably.
So they're saying on the morning, my Google says on the morning of June 30th, 1908.
Okay. That was pretty close.
An airburst over Tunguska would have created the explosion. So these are the ones, once in a century, nobody's likely to get hurt from them. But when you get up to kilometer in size, and there's an estimate that the one that created the climate change that killed the dinosaurs would have been kilometers in size. So 1 to 10, or maybe upwards of 100 kilometers. I don't quite know for sure. I think it's like 10-ish kilometers in size.
Okay. Yeah, I'm not sure. But again, moving very quickly. We still know where that one is.
Imagine 10 kilometers in size, but moving quick enough, carrying enough energy to completely disrupt a planet's entire climate.
Well, and a lot of that is the nuclear winter and the fact that we have an atmosphere. I mean, it hit in the Yucatan Peninsula in Mexico, where current day Mexico, I guess, and it's not the impact that causes so much damage. It's the fact that it hits the Earth so hard that it kicks up a ridiculous amount of dust into the atmosphere, not unlike a volcano going off, right? The volcano kicks up a lot of ash into the atmosphere that gets up into the jet stream, into the upper atmosphere, coats the entire planet after a few days, weeks, however long, and actually lowers the temperature of the planet because it's blocking out the sun. So that's the real danger. It's not like there's a bunch of dinosaurs looking around and they see this rock hit the ground and then they're vaporized. I mean, yes, some of them that were closer to the original impact, yes, but on the opposite side of the world, that's how a meteorite, I suppose, that is only 10 kilometers across can disrupt an entire planet. It's not just that it's moving fast, that it's really big, that it's really heavy, that it's really dense. It's that it kicks up so much dust that it's like a once in a millennium volcano, almost like a super volcano going off.
Now, it's my understanding that, and you can correct me if I'm wrong, but it's my understanding that all of the world's space agencies and observatories are pretty sure that we know where all of the big things in the solar system are. Meaning we know where all the asteroids 1 kilometer or bigger are, and we know that they're not going to hit us. So if we're sure we know where they all are, and we know that all of their orbits well enough to be sure that they're not going to hit us, we should be safe in assuming that our planet is probably not going to be destroyed as far as we know.
There was one a couple of years ago too, and I this one comes to mind. It was a close asteroid that kept getting closer and closer to the Earth. I think it was Apophis. Do you remember Apophis?
Apophis. No, I don't.
It was one that every Christmas time it came close to the Earth. It was in roughly Earth's orbit.
Maybe it's Santa.
Yeah, Santa Claus. So it was in roughly Earth's orbit, and it and it was getting a little bit closer to the Earth, and there was a pretty high chance, like something ridiculously high, like a 1 in 100 chance that it would hit the Earth in 2029 or something. And so every year when this asteroid passed close to the Earth, when it reached its closest approach, they scientists, I should say, and they surveyed its position, measured its velocity, updated that data, and predicted where it would be. And a couple of years ago, I think when they updated the data, it showed that it wasn't actually going to hit us in 2029. It wasn't even a 1 in 100 chance. It was much, much lower than that. But it still has closest approach to Earth every year, and it's just not as dangerous as we thought it was. And that's just one, and it was big. It was pretty sizable.
I got the size here. It's a couple of 100 meters.
Okay, so not crazy, but still a couple hundred meters is far larger than the 1 meter. Or was it 1 kilometer? You said 10 meters. What was the one you said that hit Chelyabinsk?
Chelyabinsk would have been about 20 meters in size.
Okay,
roughly.
so this is 5 times the size of that. So so pretty serious, right? But you're right. Anything really around that size, that 1 kilometer, that like, okay, now there's a serious problem if this thing gets up in our grill. We've got those under wraps, more or less.
That's what I thought. But when I think about that as, okay, we're pretty sure, and all the space agencies say, we know where the big ones are. There are prominent minds, like, say, Stephen Hawking, or others, that say we need to be a multi-planet species because it's possible that an asteroid could hit us and destroy humanity. So I think we have to take the estimates with a grain of salt. Mm-hmm. That although we're sure we know where all the big ones are, based on the statistics, we know where all the big ones are, and we know that they're not going to hit us. That doesn't mean we've seen everything everywhere.
Oh yeah, I mean, the first thing that comes to mind is interlopers, or an Oort cloud comet, right? Something that's far enough away. I mean, Oort cloud comets, they're not really doing much until they start to get closer to the sun, and then you can spot them because they start to get a coma and a tail. But even more seriously is interstellar interlopers, rocks that formed around within the birth cloud of another star that have since been ejected and are just happen to be at the right trajectory where it comes into the solar system really quickly, and because of its size, we don't see it until it's too late. So I guess the question really is, how much time do we have where we can see something like that? How much lead time do we have to prepare some sort of plan to mitigate that?
And actually, the first interloper asteroid / comet maybe has been identified, right? Did you see that story?
Yeah, because that was somebody I know, Rob Work, who...
Oh, really?
From Western, yeah. I think he did the work on that.
Oh, Rob, what's his name?
Warwick.
I know that guy.
Yeah. He's a UWO, part of the meteor physics group at the time. He's gone on. I'm not sure where he is now, but
I'm pretty sure those Pan-STARRS again. But I may be wrong. But yeah, they're pretty sure that they've found an asteroid that likely originated outside of the solar system and is on an escape orbit. So it went flying by the Earth a little while ago, just like a couple months ago, and now it's heading out. So yeah, those could happen, right?
Oh, that's one we would want to get our hands on.
Yeah, how interesting would that be? An asteroid that was born around another star that had a different temperature, different chemical makeup, different everything, different primordial conditions for its birth.
The amount of information that would give us. I mean, you look at right now we're sending OSIRIS-REx up to the asteroid Bennu, right? And so we're going to get that data back in 2023, where Bennu's going to take a sample. OSIRIS-REx is going to take a sample of Bennu and bring it back to Earth, where we'll finally get to sample this primordial object from our solar system. But imagine doing that for this interloper from another solar system. Now you have a comparison between a solar system that formed life, ours, and a solar system that, as far as we know, didn't. and chances are it's fairly close to us as well, just the amount of time it would take that rock. But would we, I mean, for one, would we be able to identify where it came from? But how similar would it be to the chemistry of our solar system, which did form life?
Dang, that would be, I never even thought of that, because like, so you're right. We should we should try and catch the next one. But trying to, so this leads back to the other question you were talking about. How do we mitigate threat, right?
Mm-hmm.
So if you want to stop an asteroid from hitting Earth, say you find an interloper that's going to hit Earth, you want to move it so it doesn't hit Earth, right? So we don't all die and go the way of the dinosaur.
Yep.
So how do you do that? And the way to do it is to change its velocity. And to do that, you need to go to it, and then you need to somehow nudge it in a certain way.
Drill nuclear warheads deep within it.
Hire Bruce Willis.
People have talked enough about how how poor that movie is in terms of scientific accuracy, so
it's entertaining.
we won't revisit that. But you're right. I mean, that it's not, you can't blow it up, because if you blew it up, you suddenly, instead of having 1 kilometer size impactor, now you have 1,000 1 meter size impactors, and I mean, that's not good either. It'll be a little bit easier for our atmosphere to deal with it, but it's still potentially dangerous, and you could get larger chunks, whatever. It's just the odds are not great. And so you're right.
You don't want to do that.
The best thing to do
sense.
is to find a way to deflect it. And the reality is you don't need to deflect it very much to get it to miss the Earth, because
if you get it early.
Sure, yeah. The earlier you get it, the better. If it even gets close to Earth's atmosphere, not only is there a chance it could hit the Earth now, but you could have altered the trajectory and have it circle the sun and come back and hit the Earth. Mm-hmm. I mean, those odds are low too, but the math is pretty straightforward for that. You can figure out how much of a deflection you need and how soon you need to do it. But then that goes back to the response time. If we have X number of months and we have a really big asteroid that we need to deflect it as soon as possible, what's going to happen? Is the world going to bind together to deal with this thing? Will we be able to? Will we have enough time to?
Sounds like the beginning of a movie.
I think so. Yeah. And I mean, I'm asking a lot of questions that we don't necessarily have the answers to right now.
I think that if we find one where the threat is a reasonably high percentage, it'll kick into high gear something that we already want to do. In fact, what we already can do, sort of, because you just pointed out that there's a spacecraft already going to visit an asteroid called Bennu in our solar system. So we've rendezvoused with comets and asteroids before. So this is something we can do. The next piece would be attempting to move it, and there's a couple of ways to do that have been proposed, like gravitational tractoring, where you park yourself in a certain orbit that nudges it just enough, mm-hmm. Or laser heating, where there's a way, if you heat just one side of an asteroid, then it would radiate that heat away out into space and then give itself a nudge when it radiates.
Yeah, it was something about vaporizing one side of it.
Yeah.
And it'll actually, and that vapor will produce a small thrust, and
exactly,
like a tiny rocket.
Yeah, just a wee little tiny rocket
with a laser. Like, it literally means like we're going to fire a laser at this thing, and it's not going to behave how you would think a laser is going to make it behave, but yeah, it makes a little thruster on the side of it.
Yeah, so there's ways to deal with it, but you need to. Like, how long is it going to take OSIRIS-REx to get to Bennu? When did it launch? Like this year?
Yeah, it wasn't that long ago.
A few months, and it's not going to get there for 2 years?
Yeah, it launched September 8th of last year, 2016.
Oh, dang.
And it's returning roughly 2023.
Okay, so you need to know that an asteroid is going to hit us like multiple years in advance. More than that, because then you need to build the spacecraft and launch it. So you need like 5 years lead time to get there. And then you need time to change the orbit. So it's not impossible, but we need to know. The earlier, the better.
Now here's the wild card in this, is that we haven't heard a lot about it lately, but there was a while where there was a lot of talk about mining asteroids.
Oh yeah.
And if you all of a sudden, if we get a push for this infrastructure to go out and mine asteroids, and we get to the point where we're able to effectively travel to asteroids and bring back economically viable materials and get good at that, suddenly that's going to make it a lot easier to get to a near Earth asteroid that could be dangerous.
But corporations will save us all.
Oh boy.
See, this is why. See, capitalism will save people's lives. Well, no, you're right though, in a sense. But I do have some. I don't believe it'll work, and the reason is, in order to get to the point where you have a mining operation that's making money on asteroids, you need to have sunk. I'm gonna estimate in the tens of billions of dollars in research and development. That's a lot of upfront cash for a company, right? So that doesn't mean it can't happen. It's going to be slow, and it's going to be, I don't know, maybe companies like SpaceX are going to take that mantle on once they've perfected putting humans like on Mars and out to the outer solar system, which they probably will do. Elon Musk is crazy. Maybe they will start attempting to mine because they have the infrastructure built in. But I don't know how much money Musk has already sunk into the development process.
Yeah, I mean, he's making his money off of going to the ISS right now.
Yeah.
And that's funding his other rocket projects and, and building Tesla motors.
Exactly.
And,
Yeah.
Among other things. But I can see him wanting to do that once he gets the infrastructure up in space where, he can send rockets up for a lot cheaper. But yeah, I agree. There's still a lot of challenges. And I was up in the Yukon this summer, and the gold mines up there rarely make a profit, right? There's some years where they make a profit and other years where they don't. And they're pulling out millions of dollars worth of gold. The problem is to find that gold, it takes millions of dollars of equipment and maintenance and man hours and all this stuff. And some years they're good and they're successful, they're profitable. Other years they're not. So, I mean, you don't see a gold rush every year now, right? If it was a really lucrative business that anybody could get into, you'd see everybody up and doing it. So it's something that, mining is a tough business, and mining on Earth is a tough business, and trying to mine in space just adds a whole other exponential increase in the difficulty.
Oh, yeah.
So
that's a funny way of looking at it.
Yeah,
mining on Earth doesn't make money. Why would mining in space make any money?
Yeah, and I can see the potential for it too, but I mean, when there was talk about that, it was kind of this wondrous thing, right? Like, oh wow, we're gonna go into space and mine asteroids, and think of the money we'd make, and how it would give us these unlimited materials that we could use. We could get into a whole discussion about rare earth metals and where they're found and why they're important and all that stuff, but it's about asteroids and yeah, there's a lot of them out there now. One asteroid in particular that we haven't found yet, I don't know if you'd call it an asteroid, is this 9th planet, and I really wanted to cram this in there.
Oh, really? Interesting. I didn't think so. I wouldn't have thought that fit into the conversation.
Probably doesn't, but I really, but I don't know. I find it really interesting because when we talk about looking for things and looking for things of a certain size, there is a limit to how far away it can be before we're going to see it, right? And the idea behind this Planet 9 thing is that we've seen Kuiper Belt objects that are all, their orbits are lined up in a certain way, and the only way that can happen is if there's something that's gravitationally shepherding them into those orbits. And so Mike Brown from Caltech and Konstantin Batygin is the other guy. The two of them did some math and actually figured out that for this to work, there should be a planet about 10 times the mass of Earth, smaller than Neptune, between Earth and Neptune roughly, way out past the orbit of Pluto, and in a specific part of the sky. Now that's amazing. We haven't found it yet. Nobody's found it, but they're looking for it.
10 times more massive than Earth, and we still can't see it. Like, that thing is, we're talking about finding things that it's difficult to find things that are 100 meters in size, and this thing is thousands of kilometers in size, potentially.
Well, yeah, exactly, and it's further than Pluto. So yeah, it's a really long way, right? Pluto's 3 billion kilometers away, give or take. a couple 100 million. But but this thing is further than that, but it's huge, and we're still working on finding that. And that's so there is a limit to how far away something is. And then if it's traveling toward us fairly quickly because it's an interloper from another solar system, how much time does that allow us before we can plan a mission, right? The New Horizons spacecraft got from Earth to Pluto in 9 years. Now, granted, it was going pretty fast, but I don't think it was much faster than an asteroid might be.
Yeah, roughly the same, yeah.
So if there's an asteroid that we can't see until it gets to, say, Pluto's distance, that gives us 9 years. Is that enough time?
No, because in my opinion, no, because say it's something, say it's the size of say it's a kilometer in size, so it's going to do some severe damage, if not destroy a lot of life on Earth. It's traveling at 50,000 kilometers an hour, roughly, directly at Earth. It takes 9 years to get to Pluto, but it'll cover some distance at the same time. So when we get to it, let's say it'll be Jupiter distance. Then you need to get to it. You can't just fly straight at it. You need to fly on an angle. You need to fly in an ellipse so that you can get into orbit with it, and then nudge it. And then when you're talking only 5 astronomical units, just Earth Jupiter distance, 4 astronomical units, that's not a lot of time to move something that massive. That's a lot of momentum, a lot of inertia, and yeah, you only need to nudge it a bit, but that's a small time frame.
Right, so that's a tall order the way things are right now.
Interesting mind game. Not mind game. What are those things that Einstein? What were they called? Thought experiments.
Yeah,
what do you call them? There's like a German word for them.
Oh, okay. I don't know the German term, but I know the English term of.
Damn it, Ryan! Learn German.
I'll get right on that. So yeah, I mean, asteroids. We should be worried.
we should be alert. I think. I wouldn't say we should be worried.
Okay, fair enough. I mean, if it right now, it's nice to know that there are very smart people working with very powerful telescopes, looking for just these things to make sure that everybody is safe. Like, we're aware that there's a lot out there, that there's potential for danger, that these things have hit Earth in the past, that, yeah, it takes a long time, a long span of time before the odds increase enough for it to actually happen. But you got to be ready for this kind of thing, right? If we want to be a species that can preserve ourselves, one of the things, and arguably one of the less important things, is protecting ourselves from asteroids.
Agreed. We just solved humanity's problems.
I think we did. So next week, yeah.
Next week, what are we talking about next week? Is it asteroids?
It's not asteroids, but it is other stuff from space that hits Earth.
Interesting.
Yeah, I like. We'll talk about Aurora Borealis, or Aurora Australis.
Okay, I was gonna say, don't leave out our down under friends.
Of course not. All right.
So the Aurora, we'll hash that out
next week.
Have you ever seen the Aurora? Yes, you have.
I saw it like a month ago.
Was that the first time?
No, I saw it when I was younger, but
okay.
Those rare times when they're powerful enough to see in our latitude.
Next
Toronto.
week I'll tell you the story of my first time seeing them.
Excellent. I can't wait to hear it.
Well, that's the end of this show. Thanks for listening.
If you want to get in touch, find us on Twitter.
My handle is @JesseRogerson.
And my Twitter handle is @AstroInAction. Check out other episodes, or just keep listening to us every week.